Yeah, so your term one marks, I think I should upload that on Blackboard. So they're composed of your four assignments, your first four assignments for the year. Assignment one, two, three, and four makes up your term one mark. Um, Again, I see that we need more time because 1 hour per week for ADP 3 is inadequate. So I would suggest that all the class reps for the three groups, group A, B, and C, should uh, should have a correspondence and talk about when you have a free time during the week. So and then you report same to me, and then we can schedule a time around your free time when everybody is available to talk about any other thing that we need to talk about and clear other questions that might be pending and admin stuff around ADP3 so that everyone is happy. Now, that being said, let's talk about tension. Um, it's it's really something expected from students when you see a very low mark and then you get agitated and you'd want to complain. But I would like to assure you that I would listen to your complaint, provided you present it in a mature and respectable manner, and then we'll talk about that complaint and talk about your marks. However, like I keep on hammering, if you actually get the concept of what I'm trying to put across to you, your marks would follow suit. Everything else would follow. On that note, again, talking about scope, you should know now that I usually don't give scope for any exam to students because that's not helping you. Because when I give you a scope and tell you that, for example, question one will be on J unit, and then you go study for the exam just because you want to pass question one, and you go study J unit for the exam. That's not helping you at all. And this level is NQF level 7, as I'm made to understand. So you need to apply your knowledge to situations. So um, try as much as possible to take your mind off of scope and exams and try to understand the concept that is being put across to you because the knowledge stays with you. And the fact that you have 0 out of 100 for a particular exam doesn't necessarily translate to you failing the course for the year. So on that note, again, if you have a very low marks that you don't expect, you shouldn't, because of that, pack your boots and hang them because until I'm done with ADP3, I'll do that next year. So one low mark or one very low mark doesn't necessarily translate to failure at all. And your marks, like I told you in the beginning of the year, there will be like two exams, two theoretical exams, and very, very many assignments. The assignments are there to boost up your marks because statistically, students are not doing well, usually don't do well in the theoretical exams. So pay attention to all the assignments that I give you and pay attention to the lectures that I put across to you and the knowledge I'm trying to give to you. And pay attention to the instructions always. And then when you have a pressing issue, contact me and we'll take it from there. Now, for those of you that contacted me over the break and I didn't respond, yeah, it wasn't intentional. I was unwell. So, that being said, I think I'll just show you. Some of you requested to see the memo. I don't think that's done in CPUT. Is it one of the school's policy to send out memos to students after the exam? Can someone help me here? Yes, Mr. Ross.
Hi, sir. Yes, it is school policy. I'm just trying to find the student's rule book. But as lecturers, you're supposed to give feedback on marking criteria, and it is in the school code of conduct.
Okay, thank you for that. So let me share my screen. Um, you should see my screen in a couple of minutes. So on the left side, I have the memo. On the right side is the question paper that you guys have. So we'll start with this. So that's a typical memo for that. Now it made all this blah 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 here, and then the problem actually is here, the problem description. So it says the accounting system should manage customer accounts. So now it says each customer has a mandatory unique identifier. So this is the customer here with an ID, the first name and the last name, and that's depicted in there. Then it says a customer also has identity information, which consists of type of identification. So this particular statement is very loaded, so you need to separate them. And you should know that your entities are the nouns in your statement. Customer is an entity, identity is an entity. That's why you have customer identity here. And then type of identification is also an identity. That's why I have a type of identification. And then it says the customer must have at least one. This at least one, it shows the kind of relationship. At least one points out the type of relationship you have between a customer and an account on the phone accountant. So a customer must have at least one. Then an account must have a unique account number. And then up here you see an account with an account number, the running balance as account balance, and the date it was created. An account also has an account type, and that's what you see here, an account type. And this relationship depicts an aggregation, and that is the one-to-one mapping. So that means a customer cannot have an account of the same type. A customer cannot have two savings accounts in a particular bank, for example. And that's about it. So marking here, the entities have 2 marks, totaling 12. The cardinalities of 1 mark each, totaling 8. That's why the marks is 20 marks. Now, I don't pay attention to this. If you use composition or aggregation here, it doesn't matter. It doesn't add to your mark. It depends on your ideology of how you want to implement this. But the cardinality matters. A customer can have one or more accounts. You can only have one identity type in a customer identity. Same as this, you can only have one account type in there, and same as this. Now, this is the base. This is not the only correct UML. So it's marked. This is actually the base for marking, but this is not the only correct stuff. So when I go through your stuff and I see there's something that are correct that are not in what I have here, you still get the mark. So that's for that question. It says assume you're the team lead in question 2. Describe how you would set up the code base. Keyword is how you will set up the code base. and manage work done by the rest of the team to enable efficiency. Now it says, the marking says, the student should demonstrate knowledge of build tool with examples, that's 5 marks, and knowledge of how to set up and manage a project on a distributed version control system such as GitHub, that's 5 marks. So I see some of you were talking about repositories and all have you repository services, builder pattern. That's not exactly what this is talking about. It's talking about how you set up the code base and manage work done by the rest of the team. So this is talking about one of the first classes we had during the year. I've forgotten the name of that lecture. Yeah, so it's talking about build tool and GitHub. Some of you talked about JUnit testing stuff in your answers, and then you got marks for that. So the other question is this code snippet with first, second, third, and then you're asked to identify the design principle violated in this code snippet. So the answer to that is principle of least knowledge, also called law of Demeter, and that's 2 marks. Describe the design pattern that solves the design principle violated in problem statement 2. Facade solves the principle of delimiter. There are other design patterns that solve this, but this is used as a base. So when I read your description and see that your design pattern that you've chosen solves the violated principles, then you get marks for that. The UML diagram is 3 marks for that. And the UML diagram, I have this for the facade. I wanted to say something here. Okay, going forward, problem 3 is a bunch of if-else, and it also says identify the principle violated by the code snippet. And the answer to that is the open-close principle. And the use of chain of responsibility design pattern will be suitable, and that gets 5 marks. So you have to, the keyword is describe. When you identify the design pattern that solves the principle, you have to describe it, showing that you have knowledge of that design pattern. And that gets you 5 marks, and then the UML diagram gets you 3 marks, and that's the end of the exam. So that's your that's the memo for the exam. So now, if you have issues with the marks that you have according to this memo, kindly send me an email pointing it out, and then we can look at it together. But however, I would like that conversation to be online, as in it have to be you have to simulate a face-to-face conversation, because sometimes attending to emails might not deliver the required result. However, you just send me your email showing what you think you should get and where you need to, where you think there's a mistake in the mark, and then we take it from there. What next? Instructions. It's very, 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 very important that you follow instructions. Very important. There are a bunch of instructions listed on Blackboard as an announcement and during the exam, and each of these questions also had instructions. Some of you didn't follow those instructions. One of the instructions was to send in your document or your attempt as a Word document. And if you need to draw any diagram, use any UML tool, take a screenshot and attach it to the document. Some of you sent me a zip file. So kindly try your best, possible best, to read the instructions and try to follow it. Okay, so any question around this before we move ahead? If you need to say something, can you kindly raise your hand and I'll call on you to say something? Any question, comment around the memo? Yes, Mr. Ronald.
Hello, sir. Well, I just have a comment in terms of what do you call them, the memo, not giving the memo. So, sir, sometimes the work can be too much, and obviously we're not gonna be able to catch like everything 100% from when we started to when we're gonna finish. I think we can always fill the gaps like when we go into the industry. So when you give us a memo, at least we get to master the stuff that you want us to master, and the rest we can fill in the gaps.
Okay. Okay, that point has been taken. Thank you for that. Any other person? Okay, so let's do a quick recap of what we've been talking about since the beginning of the year. Not this. Um, so, um, the story is we're trying to write industry standard code. I'll try to be very brief as possible, and please try to follow me, and I'll make notes on the mistakes I've seen based on your assignment and the exam. So the story is that we're trying to write industry standard code, and that means that you're trying to solve a particular problem in the most efficient way. There are very many ways to solve a problem. A piece of code can actually do what it does, but if you relook it, you'd see you can redefine and tweak it to make it better. So one of the ways to do that is using domain-driven design and test-driven development. So domain-driven design means that you need to have knowledge around the domain that you're trying to build. The domain here is defined as a problem space. For example, the health, banking, um, entertainment, these are domains. So in a domain, you can drill it down to a particular thing. For example, banking is a very wide thing. Health is also very wide. Entertainment is also very wide. So when you drill it down to a specific problem space, you identify the problem. That means you need to have knowledge around the domain. And then you build all the domains now. In this case, your domain refers to actors, all the actors that are key players in your problem space. And your actors are divided into, or they're actually one called entities. Those are your actors. And then you have value objects that looks like entities, but they don't have a unique identifiers. And then you have aggregates, which is a collection of entities and value objects with an aggregate root. So in domain-driven design, there are different um, building blocks, about 8 of them. I just talked about entities now. Value object is another, aggregate root is another, repository is another, factory is one, and then services. So in a code base, representing all those things in your code base just means that when you start a code in any particular IDE, well, before we get there, we talked about package management and software development infrastructure, which talks about your GitHub, which is a distributed control version system, and a build tool. An example of that is the Maven, and then a testing framework. An example of that is the JUnit. So these are software development infrastructure that helps you code faster and more efficiently instead of using the conventional text editor, Notepad or Notepad++ or any of or what have you. So to structure your code in any particular IDE, you use a build tool that helps you develop faster and deploy faster. And we're using Maven here as a build tool, and we're using IntelliJ as the IDE, and our testing framework is JUnit. And then our packaging principle says that you need to have your domain as the default package. If you can see my screen is highlighted. Your domain is your default package. So if your domain in the conventional sense of the internet world is www.abc.com. So abc.com is your domain. So when you invert that, it's going to be com.abc, and that's your root package. Then if you're developing more than one applications, then you should also include that in your root package. So it can be, if this startup has an entertainment application, a soccer application, a payroll application, then it's likely you'd see com.startup.entertainment. But we didn't get to that level here. Then subsequently, your sub packages are divided into these that you see now, because we're building this on the go. So we've looked at entities. Entity package contains all your entity, value, object, and aggregate roots. So, and then in there's also some form of packaging principles that groups all similar things in a particular place. In this case, I have user package and demography package. Under demography package, I have things like race and maybe role and maybe gender. They're going to fall under demography. And that's just to make the content of your entity, presentable. So, and this particular presentation follows through in every other thing, every other building block of your domain-driven design. And then we talked about having your entities designed using the builder pattern. So the builder pattern has a private instance variable. It has getters and then a toString if you want that. Then it has a public static inner class that you can name anything, but in this case it's called builder. It has, and your inner class, your inner static class should have the same instance variable as your main class. And then it has the setters that returned an instance of the builder. So each of your setter returns an instance of the builder as soon as you set whatever you need to set. So in this case, the ID is setting the ID that comes from outside. It does that in line 32 here, and then returns an instance of the builder. Same as line 36 that sets the description. It does that in line 37 and returns an instance of the builder. The builder class also has a copy method that returns an instance of the builder. And this copy method gives us a copy of a particular object that we need. So it takes in that object, assigns all the variables of that object to the variables of the builder, and then returns an instance of the builder class. Then the final most important one is a method that returns the actual object that you're trying to build. In this case is race. That method is usually called build, and it calls the constructor of the main class race and passes the instance of the builder class. Now we've made the constructor private that was hidden from the external world, and then it takes in all the attributes of the builder and assigns them to the attributes of race. And there you go, that's an example of your builder class. So this is an entity. Now remember that an entity is just a plain old Java object, a Java object with attributes and the getters and setters of that attribute. So you have the getters here in the case of a builder pattern, and then you have the setter here inside the inner class. Then the next building block of domain-driven design is the factory. Now the aim of the factory is the factory is the source of all instances of your entities and value objects and aggregates. So if I need to create an instance of this class, I do not have to call this class or call anything in this class. I would have to look for the factory that gives me the instance of this. So in this case, I have a race factory, and it has a static method called build race that returns a race, and it takes a race description. Meanwhile, my race has ID and description. But what you're trying to do here, you're trying to build a race. Now, in an ideal situation, when you're trying to build a race, you may not necessarily know what the ID is. A perfect example is when you're trying to register a student in CPUT for the first time, you do not have the student ID. So you have every other information that you get from the student, like the student's first name and last name and address and cell phone number and every other thing. And then you use that, send those into your system, and your system gives you a unique student ID. So that's what I'm trying to depict here. At the point of creating a race, we do not know the ID. That's why I only require the description of the race from the user that's trying to create a race in this system. So that's the case. That's the most kind of mistake that most of you did. You passed in the ID here. That means you're telling your user that he is responsible for creating an ID and sending to you. Now, if I have 10 users that want to create something on my system, they want to create a race on my system, and each of these 10 users have the responsibility to create IDs. Now, there is a very little chance that these IDs might not be unique. So to make sure that these IDs are unique, you have to take up the responsibility of creating the ID yourself. So the user is only going to give you the description. So when the user gives you the description, there's a utility folder here. This is my coding convention. You can have any coding convention you want. I don't want to impose this on you. This utility is way off the topic we're discussing about. But it's just a utilities contains all my helper classes that helps me achieve my domain-driven design thing that I'm doing. So I have a generic class here with a method, a static method, that returns a random number each time I call it. So in this case, I called it here to give me a race ID, and then I pass that as a race ID and the description in here. And this returns a race for me, and I have a test case for this. Remember, this is test-driven development. You need to have test cases for everything you do. And that test case is in here. So this test file highlighted simulates a client. So that client wants to create a race, and that race is African. So he just sends in African, and he gets a response from my system that has been created with a particular ID. And that's what you see here. And this is the ID generated from the system using that helper method. Now there's a second level I did, which I just did this morning. If you see, there's a line here. Now, if you're trying to put in the content of this should be one and only one task. The task in here is to successfully create an instance of the race class. You shouldn't do any other thing. However, if you have business logic that enforces a particular rule when creating an instance of your class, you can put them in here. For example, this says that if you send me a description that is empty, you can send me an empty string, then I'll comfortably return an empty race to you. No harm felt. That's just something I thought about. So I'm just trying to make you understand that the idea around the build method in the factory is only to create instances of that particular class that you're trying to create. Now, all the rules that are associated with that can be enforced in the body of your factory method. Now, this is a string helper that I created under my helper class there that tells me whether a string is empty or null. So it takes a string and says if the string is null, return true. If the string is empty, return true. If the string contains is the same thing as null, return true, else return false. So if I send in here, if I send in something like this, it's going to return an empty race. Like you see, this asset is now false. Okay, let me take this off so that you see what it returns. But you see that it now fails, which is right, because it didn't create an ID. So you see it gives me a null. And if I send in null also, because null is not an acceptable string, in this case, it also gives me null. So until you send something that should make sense, it will not generate an ID. Now, that's just my way of thinking. I'm not going to tell you to enforce that. You need to know all the things around your domain and what you need to do around your domain to create a factory. Now, another reason why we need the factory is that it has hidden the complexity of creating a race from the end user. This is the end user. The end user thinks that when you just give him a description and call this method, he gets a race. Now, the complexity has been hidden from this client, and the complexity is hidden in the factory. And that's why you need the factory. So that's another building block of domain-driven design. Then we go from factory, we go to the repository. Now, repository talks about persistency, saving your entities to an aggregate root to a form of data store. So I'm talking about race here. So I started with an interface. The main interface in the repository package has all the common or most common operations done on a persistent data store. You create, you read, you update, and you delete. And it takes in a form of parameter, and this is the type, and this is the data type of the ID of this type. This can be anything, it can be S. When it's S, all these things has to change. But T is just to make it easier to explain. So T can stand for type. Now this type is the type of entity you're trying to save. And then this ID is the data type of the ID that uniquely identifies the type. So that's the main repository, main interface. Then we come to the race. Race falls under demography. So in demography, we also have an interface that extends the main interface, and you see now it passes the type. The type is the type of the entity we're trying to perform these operations on. is race. So let's go to race. Race has a unique identifier called ID, and the data type of that ID is string. That's why we have string here. I hope that's clear. Then this interface has all the unique operations that has to do with race can be in here. And then you have an implementation folder with race, with a class called race repository implementation that implements the race repository. So when you do that, you would need to override the read, update, delete, and get all. Now this 4 is found in the main repository. The create, read, update, and delete is found here. And the other one, this one, is found in the race repository. So this is the main implementation. So in this case, we said that we're going to use a data structure to simulate a persistent data store. And I've chosen to use the set, and that set is made up of races. So I called it race DB. And then I told you that your race repository is what it acts like a point of entry to your data store. So if I have a race DB, I need to coordinate access to this DB because it's only one and only one DB. So if I have multiple access to this DB, there might be data inconsistency. So to ensure that there's only one access to this DB, I need to implement singleton. And to implement singleton, we have a race repository here that we initialize to null, and mind you, it's static. This race repository is the interface and is initialized to null. And then I have a public static method called getRepository that returns a race repository. So what it does first in line 19 is it checks to see that the repository is null. If the repository is null, then it instantiates the concrete class race repository that implements that race repository. And then it returns that. So this enforces that you have only one and only one instance of the race repository. So you only have one access to the DB. So anybody that calls this would first of all have to call the get repository. And we can see that in the client depicted in the test case race repository. So you see that it's in line 14 here, there's a private static race repository, and it calls race repository implementation.get repository, which is this. And it first of all checks to see that this is null. If it's null, it instantiates it. If it's not null, it doesn't even go in here. It just returns that instance that already exists. So this enforces one and only one instance of this race repository implementation class forever. Now, our database is RESTDB. I implemented this to be the method that adds into the set. So to add to a set, you just need to call the add method and return what you add. To read, you just need to iterate through the method, iterate through the element in your race, and return if you find it, like this, for race R in this, in this.race db. If race dot, let me just comment this out for those of you that have problems with it. If race dot get id dot equals id, and return race. So So this is another example. This how to you just iterate through the list that you have and find the particular one that corresponds to the ID that has been passed in here, and then you return it. But if it doesn't find it, it returns null, which is the same thing I did in this line. Then to update, okay, before we go to update, let's go to delete, because I see update uses delete. So to delete, you pass in the ID, and the ID reuses, the content of the delete method reuses the read. First of all, we want to check that whatever you want to delete is in your database. So you read, and it calls this again to read. So if it comes back not null, then it removes it. And then it returns true. I just decided to have a return method here. So if you've successfully deleted an element from the database, it returns true. If it wasn't successful, it returns false. This is not mandatory. You can return whatever you need to return here, depending on your coding principle, but make sure it's a standard return type. Or you make sure that it corresponds to your business logic and your business rule. And that's for delete. And then get all just returns the entire database. Now, coming back to updates, we see that first of all, I have to delete the one that's in there that corresponds to the race you want to update. So I get the ID of that race and I delete it. If deleted, then I can add this new one and then return the race. But if not deleted, I return null. That means the update wasn't successful. Then a test case for this is seen here. So the story around the test case is that you want this to run sequentially. So you want it to run, first of all, you want to create, then probably a read, an update, a get all before it deletes. So to enable that, there is an annotation called fix method order that takes in many parameters. So there is name ascending, there's default, and then there's JVM. So I'm going to use name ascending. So it sorts your method in an ascending order. Then I appended A, B, C to enable it to sort it in an ascending order. So A does first before B, then C, then D before E. And then I have a static method, a static class variable called repository that gets the instance of the repository. And then I have a race that I'm trying to manipulate in the repository. Then the create calls the repository to create that race, that's this race. And the asset equal checks that the created race corresponds to the race that was built using the factory. So this race is the one that was built using the factory, and this is the one that's being saved in the database. Then the read just gets the ID of the one that was built from the factory and checks if it's in the database using the repository. And then the update, first of all, makes a copy. Now, this is an example of when you use the copy. Once you create an instance like this of a particular entity or value object using this, you cannot modify it. If you want to modify that, you need to create a copy first before you modify it. And that's what you see here in line 32. I created a copy of race. Now this race corresponds to this that was built using the factory. So I created that copy, and then I modified the description of that copy to that. And then I called the build to have an updated build. Then I called the repository to update that, and that's for update. Then delete calls the repository to delete by ID, and get all calls the repository to get all. Now you see that this repository is just one and only one link to your database. You shouldn't have multiple of these. This is implemented using singleton. That's very important. So if I run this, you'd see that they'll run sequentially and they will have the same ID. So you can see the race here has African, and it was created with this ID. Then I saved that in the repository. So created, which is this, points to this one on line 19 that was saved in the repository. And the ID of that one that was saved corresponds to the ID of the one built by it in the factory. And you see it has a misspelled African. Then I read using the ID. So I go to check in my database using the ID of this, and then it returns with that, meaning that it was successfully saved and can read it. Then I go to update, I create a copy, and then I change the mistake and I correct the mistake to African. And I see African is corrected now, and the same ID, because we're dealing with the same repository that points to the same, that handles all the connection to the database. Then I get all. There's only one in my database, so it returns one. And then I delete. And that's the story behind repository. Do we have any questions to ask around this? So the reason you need, let me start afresh on the repository. Close all. The reason you need this main interface is because all the repository would have to do these four most common main things: create, read, update. And it should take a type and the data type of the identifier of that type. Then each of your stuff, each of your entities will now have their own repository interface that extends the main repository. And then you'd have an implementation folder that has a concrete class that implements a particular type of repository. In this case, we're implementing a data type, a data structure repository called set. So the idea here is when I have this main repository and this sub repository, sorry, this main interface and this sub interface, I can have multiple implementations of a particular repository. Now this implementation is only on race, on a set. I can have one that speaks to a MySQL data store, and another one that speaks to a Cockroach DB, and another one that speaks to a Cassandra DB. Now this makes it easier for you to extend your code instead of modifying your code. You just have a repository interface that you can extend. So this is the principle of, or this is the fundamental implementation of polymorphism. And this is the case you use implement and extend. For those of you finding it difficult to understand why I say run away from extension and implement here, not that they're not necessary, but do not use it in your entities and value objects and what have you. So all the extents that you have here is going to give you issues. And make sure that they stand alone classes. And then where you see the benefit of extend and implement is in the repository and the services. So this is an example of a repository which you are now to implement on your group project. So your assignment for this week will be to implement repository. We're continuing from where we stopped. Implement repository on your projects. So as usual, your group lead should assign tasks to all group members, and you work and update your GitHub, and then submit your GitHub. But I'll put up the assignment details on Blackboard. Again, I would like to ask and plead with you guys, try as much as possible to follow instructions. And when there's a conflict, try as much as possible to present your conflict in a very mature way and not disrespectful. Now we in this era of pandemic, so it's very difficult to manage a class, not a class as large as ADP 3. You guys are over 100. So I've created, we have a mail thread for your project. So all the problems you have or communications you need to do around your project via email should always be in response to that mail thread and must have all your group members in copy so that everybody knows what is happening in that project. Whether you shouldn't make a decision that that is a personal thing. If it has to do with your group project, it's no longer personal. Just put it up there. And the group leads, one of your groups have not sent me your group report. I think that is trying to verify now. Um, one moment, please. Group 9, your group lead hasn't sent the group report for assignment 6, or rather she sent it to me alone. Now he or she needs to send it so that all the group members see the group report. So it needs to be in copy in response to the mail thread and must have every group member in copy. So yeah, this is the end of this lecture. Do we have any question on repository? This, by the way, is the third lecture on repository. So there are 3 sessions now on repositories, and this should be clear. Try as much as possible not to use my coding standard. Try to use yours. Think of ideas and use it. Any questions around repository? Mr. Elvis. Elvis, go ahead.
Hello, sir. Can you hear me fine?
Yes, I can hear you.
Okay, I just want to ask about, let's say you had a minute-to-minute relationship. How would you deal with that?
Sorry,
Would you have like,
what relationship?
let's say you had a minute-to-minute relationship. How would you deal with that? How would you deal with? Would you have like a bridge entity? And if you would have that, how would you have? How would you deal with the idea of that entity? Because I have a minute-to-minute relationship. I'm trying to figure out how to do that without using a tool here.
Can you give me the example of the many-to-many relationship so that we can solve it practically?
So, okay, so I have sell and product. A sell can have many products, and then but the product can belong to many cells. So I have a cell product as like a bridge entity, but yeah, that's. And if I have like a repository for that,
So you have
I'm trying to
selling,
sell
right?
sell and product.
Sell,
A cell, not
sell like that.
no SAL.
Oh, sale.
Sale. Oh, sorry, sale.
Okay, and then you have
product.
product.
Yes.
So, and you have a many-to-many between these. But this
Yes.
has a product ID, right?
Yes.
And this has a sale ID.
Yes.
So one way to solve this is to have a bridging class called sale product
Yes.
or product sale. Anyhow you want to name this
That's
that makes sense to you. Product sale or sale product, and now it has um, string sale ID and then product ID. This should solve your problem.
yeah. And then I'm trying to make that as one ID for my repository because I just want to pass one ID when I want to create.
When you want to create what?
If I want to create I want to add a cell product to a cell. If I have a cell product repository, my create method should only pass one ID, or it can pass both IDs, like the cell ID and the product ID. That's what I've done, but I don't know if there would be a problem with you, or I should make that I should have only one ID, maybe by concatenating both IDs or something like that.
No, hold on. Let me try to understand. What are you trying to create? Are you trying to save this in your repository, sale product?
Cell product repository. If I have that, then my create method will need to have an ID or my update.
No, not really. This acts as your ID. The uniqueness of this of a sale product is the sale ID and product ID.
Okay,
So
so
if you have,
if I want to search for product ID, so I need both the cell ID and the product ID. I need to pass both those IDs.
no, the uniqueness of this sale product is in the combination of the product ID and sale ID. So you can have something like this. Let me explain it. Can you see my screen?
Yes.
You can have sale ID to be one, product ID to be ABC, and also have sale ID one again, product ID as this. So you see this combination and this combination are not the same, even though they have the same sale ID. So if you want to
Yes.
query all the product under a particular sale ID, you just need to pass in one and it gives you these two products.
Okay. And okay, and if I want to check if a product is part of a cell.
So when you send in, that means you need to pass in both the sale ID and the product ID.
Yeah,
Because if
yeah.
you want
So
to
that's
check
what I was thinking
if
about.
you want to check if AAA is part of this sale ID one, that means you already know the sale ID. So you need to pass in AAA and one.
Yeah. So
But
that was my problem.
if you need to get all the sales in which AAA appears, which can be also a valid um, query, you can have something like this, two, and then product ID, AAA. So if you send in a query with product ID AAA, you have two sales, sales one and sale two, where product ID AAA appears. So this is a many-to-many
Okay.
relation.
Okay. And then can I then have a different interface for cell product that doesn't extend from the main repository, the interface? Will that be a problem?
I don't
Because its
understand what
read
you mean
method
by
might read, okay, because its read method might take two parameters. So if
oh
it
yeah.
will not,
Okay, so that's a perfect
yeah.
example. Yeah. That's a perfect example. In your case, you need to have something like this. Um, uh, Java class, sale product repository. It's an interface. extend my repository. Now there are many ways to do that. Oh, I don't have self product. Do I have self? Yeah, I have self product. And then so you see that the uniqueness of your self product has to do with two IDs. So you cannot
Yes.
use this repository, right?
Yes.
So you can keep to use this repository, and then you create your own unique stuff here. You can have
Okay.
still product create string still ID and product ID. So this is a perfect example of what you need to do. You shouldn't
Okay.
extend this. Now this is the most common, but when you have something that doesn't take in these two, then you can do your stuff like that.
Okay. Thank you, sir. That's all I want to know.
But you can also research on any other thing, any other way possible. This might not be the only answer to it. This can also take in cell, cell product. And then in your cell product here, you implement, not implement here. You do that stuff, equal and hash code. So here you're going to say that for two cell products to be equal, they must have the same cell ID and product ID. And the hash code is also defined by this. So, and this must also not be null. So this means that when you're checking the equality of a product, it means that the cell product, two instances of the cell products are equal if cell ID and product ID are equal. That's what this is doing. But that's another way. Just research on the ways to do it. But this is not the only way. This is just the most common instances. When you have something that doesn't follow this pattern, that's why you have interfaces. You can implement yours. Any other question? Any other question? Okay. I will be uploading. I think that's also part of this CPUT's guideline that we need to upload term 1 marks to you to see. So I'll upload term 1 marks for you to see. Now, your term 2 marks comprises of your exam and your 2 assignments, 5 and 6. So make sure that I have marked your 5 and 6 and term 1 exam and the exams. Make sure that I've marked those. And if you have issues with any of your marks, kindly send me email so that we can take it from there. Questions, comments? Okay, thank you for your time. In the absence of any other thing, thank you for your time and have a nice day.